Bismillahirrahmanirrahim. Hello everyone. This is our third method, which is called the noise terms phenomena. You can consider it a method, and you can consider it a phenomena that appears when applying the Adomian Decomposition Method. Of course, that was the first method that I illustrated, but you can consider it a method because you change some steps. Okay, let's begin. As you can see, I consider it a method. So the steps of the method, the first three steps are the same as the Adomian Decomposition Method, and then it differs. First, we let u of x equal to the summation n from 0 to infinity un of x. So when we expand it, we get u of x equal to u0 of x plus u1 of x, and so on. We substitute with u of x in the linear Volterra Integral Equation. Third, we write the recurrence relation, where we put u0 of x equal to f of x, and then we write un plus 1 of x equal to the lambda, the integration from 0 to x, k of x in t, un of t dt, where n is greater than or equal to 0. What about step number 4? In step number 4, you check if there are noise terms when adding u0 plus u1. I mean, if there is part of u1 that is cancelled with part of u0. If so, this part, which is minus and plus, this part are called noise terms. Okay? Then you claim that u of x equal the part of u0 of x that is not cancelled. Okay, if we did not find noise terms, we evaluate u2 of x and then add u0 plus u1 plus u2 and see if there is noise terms or there are noise terms or not. Okay, after that we write our claim according to the cancellations. And then in number 5, you check if u of x that you claimed is right or not. Of course, by substituting in the integral equation and see if the right hand side equal to the left hand side. If so, then your claim is right. If not, try something else. Okay? To make it easy for you to understand the last steps that I have mentioned, let me explain it for you in this way. If we have, for example, u0 equal to a plus b, and u1 is equal to minus a plus c. Okay, so we have here the noise term. The noise terms are plus and minus a. So from here, plus and minus a are the noise terms. Okay, so if we add u0 plus u1, these terms will vanish. What is our claim? Our claim is that u0 of x, u1 of x, u of x equal to b, which is the part that is not vanished when adding u0 plus u1. Okay, then what do? We substitute in our Volterra Integral Equation. Okay, so we write b equal f of x plus lambda, the integration, plus lambda, the integration from 0 to x, k of x in t, b d dt. Okay, I don't know if b is a constant or not, okay, but whatever is b, you substitute in the Volterra integral equation and then see if the left hand side is equal to the right hand side, then we are lucky and our claim is correct. Okay, I hope you get it. These are the examples that I have backed. Let's do the first two and you do the rest. This is the first example. Of course, we are using the noise term phenomena, so we will use the same steps of the Adomian Decomposition Method. We first let u of x equal to the summation un of x, where n from 0 to infinity, and then use the recurrence relation of the Adomian Decomposition Method, where u0 is equal to 6x plus 3x squared, and then the rest will give us uj plus 1 of x equal to minus the integration from 0 to x uj of t dt. Of course, where j is greater than or equal to 0. Now we can get u1, which will be equal to minus the integration from 0 to x u0 of t dt. Okay, so 6t plus 3t squared dt, and this will give us minus 3x squared minus x cubed. Okay, now let's see if there is nice terms or not. As we can see, there is nice terms, so we'll write here our nice terms are plus and minus 3x squared, because if we add u0 of x and u1 of x, so if we add u1 plus u0, this term will vanish, okay? Or these terms will vanish. So we will claim that our u0 of x, again not u0, so we will claim that u of x equal to the part that is not vanished from u0, which is 6x, and then we will substitute in our integral equation. Okay, so let's put here the left hand side is equal to 6x, the right hand side should be the same, equals 6x plus 3x squared minus the integration from 0 to x to 6x and dx. Okay, and we can see here that if we integrate this, it will give us 3 minus 3x squared. So this part will go with that part, leaving 6x alone. So the right hand side is equal to the left hand side. So our claim is right. Okay. That's the second example. Okay. We have also to use the same method, which is called the nice term phenomena. The first step is we write u of x as a summation of un of x, where n from 0 to infinity. And then we use the recurrence relation of the Adomian Decomposition Method. U naught of x will be equal to the f of x, which is 2x minus 2 sine x plus cosine x. Let's write it down. 2 sine x plus cosine x, and uj plus 1 of x will be equal to minus the integration from 0 to x minus t squared ut dt, ujt dt, where j is greater than or equal to 0. Now let's evaluate u1 of x. u1 of x will be equal to, of course here we will substitute with j equal 0. So it will be equal minus the integration from 0 to x minus t squared u naught of t dt. And this will be equal to minus the integration from 0 to x squared minus 2x plus t squared. Okay, u naught of t is 2t minus 2 sine t plus cosine t dt. So let's integrate this. We have here x squared, it's a constant, so when we multiply it by this bracket, it will never affect the integrations of t and sine t and cosine t. So that will give us minus x squared will be the same, but here we have t, so it will be t squared over 2. 2 will go with 2, and it's from 0 to x, so it will be x squared. So we will have x raised to 4. Okay, the second term will be negative and negative, so it will be positive. There is 2, and we have here sine, so x squared will not be affected. Sine t, the integration of sine t is minus cosine t, and it's from 0 to x, so we will have minus cosine x minus, so it's going to be plus cosine 0, which is 1, and then we have minus and positive here, so it will be minus x squared. We have cosine t. The integration of cosine t as sine t. Sine t from 0 to x will be sine x, because sine 0 will be is 0, so it will vanish. Okay, the second term we have minus 2x. Again, it's a constant, it will not affect the integrations. Wait, this is not minus 2x, no, it is right. It's minus 2x, but there is t, because our kernel here is x minus t raised to 2, so it's x squared minus 2xt plus t squared. So there is t here, it will affect the integrations here. So and we have here minus and minus, so it will be plus 2xt. We have here t multiplied by t, which is t squared. T squared, when we integrate it, it will give us t raised to 3 over 3, and then that's from 0 to x, so we'll have x raised to 3 over 3, but there is x here, so it will be x raised to 4 over 3, but there is here 2 multiplied by 2, which is 4, and then we have 2xt multiplied by minus 2, so we have minus here outside and minus, so it will be minus 4x, and we have t sine t. The integration of t sine t I evaluated, and it will give us sine t minus t cosine t. How to read this? It's the integration of x multiplied by sine t, and this is the answer, and the integration of x multiplied by cosine t, and this is the answer. And here for x squared multiplied by sine t, or x squared multiplied by cosine t. Okay, so here we will substitute with the integration of t sine t from 0 to x, which is sine x minus x cosine x. Okay, and then we have here minus and minus positive, and here it's positive next to the cosine t, so it will be plus 2x, the integration of t cosine t, so, which is this part. Okay, so you write it down. It will be cosine x plus x sine x minus 1. Then we have the last term, t squared, to this term, plus we have t squared multiplied by t raised to 3. When we integrate it, it will be t raised to 4 over 4. 2 over 4 is half, and x raised to 4 from 0 to x, I mean t raised to 4 from 0 to x, will give us x raised to 4. Okay, and then we have t squared multiplied by minus 2 sine t. Minus 2 will remain the same. We will write the integration of t squared we should never forget that there is minus here outside, so it will be plus. Okay, and here also it's plus t squared multiplied by 2t. When we integrate it, I forget the minus, so I write it down here, minus. Okay, so the integration of t squared sine t, I write it here, so let's write it down the same, which is 2x sine x minus x squared minus 2 cosine x minus 2. Okay, and then again the minus outside, and here it's plus next to t squared, and next to cosine it's positive, so we write minus the integration of t squared cosine t, which is this part. Okay, we have to write it down, 2x cosine x plus x squared minus 2 sine x. Okay, now let's see the similar coefficients and add it to each other. We have here x raised to 4 minus is multiplied by minus 1, and here it's multiplied by 4/3, and here minus half. So we have minus 1, let's write it as minus 3/3 plus 4/3 minus 1/2 multiplied by x raised to 4. So the first two will be 1/3 minus 1/2 here. That when we multiply here by 2 up and down, here 3, that will give us minus 1/6. So the coefficient of x raised to 4 will be minus, it's minus, yes, x raised to 4/6. Okay, and then let's collect the coefficients of cosine x. Okay, cosine x is multiplied by minus 2x squared, and here it is multiplied by minus and minus, plus 4x squared, and here plus 2x, and in the last line we have minus 2x squared plus 4, and finally here we have minus 2x. Okay, what about the sine? Okay, sine x is multiplied here by minus x squared, and here minus 4x. Okay, and here plus 2x raised to 4. At the last line we have 4x, and here we have plus 4x. We have minus x squared plus 2. Okay, then we have for the x squared only, we have 2x squared, so we will write it here, plus 2x squared, and here in this bracket we have 2x, so minus 2x, and here we have minus 4 only. Okay, now we will do some simplifications. Okay, so let me clean the part and come back again for you. The coefficient of cosine x, we have minus 2x squared, and we have 4x squared and minus 2x squared. So this will go together, and we have 2x and minus 2x. All of these will vanish, and we just have 4x. So we should write 4x, 4 only, sorry, plus sine x, and in sine x we have only the two things that will go together, plus and minus 4x. Okay, what will remain? 2x raised to 4 minus 2x raised to 2 plus 2. Okay, now we should look at u naught of x, which is the f of x here, which is 2x minus 2 sine x plus cosine x. Let's search where are the noise terms. Okay, first of all we have here minus x and we have plus x. So our noise terms, plus and minus 2x, and we have here minus 2 sine x and plus 2 sine x. So plus and minus 2 sine x, and there is now here minus cosine x. So those are the noise terms. What is the part that remains when adding u0 plus u1? From u0 it is cosine x. So the claim will be u of x equal to cosine x. We have to check that by substituting in the Volterra Integral Equation. Let's use the Mathematica to check our answer, if it's our claim, if it's right or wrong. This is a sheet in Mathematica. First we will define u of x. Write u squared bracket x underscore and equal to cosine x should begin with capital letter, and it's a function, so we have to use the square brackets. Enter. Then we have to write the right hand side, and we should have the answer as cosine t if our claim is right. So 2x minus 2 capital letter S sine squared brackets for x plus again capital letter for C sine square brackets for the x minus escape din double t again escape, so from 0 to x minus t control 6 square, so 2 u u of t dt. Enter. Okay, we have to full simplify it. Full simplify. So we have cosine x, so our claim is right. So our solution is u of x will be equal to cosine x. If you don't know how to integrate x sine x and x cosine x, also x square sine x and x square cosine x, I'll explain it in the coming slide, okay? These four integrations, we need their values in the example that we are solving. These four integrations can be solved by parts. Why? Because we have two functions that are multiplied. Which one of them, when we differentiate it several times, it will give us 0, okay? But the other one will not. So we have here t. If we integrate it twice, it will give us 0, okay? We have here t again, and here t squared. If we integrate it 3 times, it gives us 0, and here t squared, okay? But of course, cosine and sine will not give us 0 if we differentiate it in time. So let's begin with the first integration. We will take t as the u, okay? And u we differentiate it, and we will take sine t as dv, the part that we will integrate it, okay? So let's differentiate t. It will give us 1, and then it will give us 0. Sine t integrated will give us minus cosine t, and then cosine will give us sine t, and the minus will remain, okay? And then we will multiply this by that, this term with that. Here it will be positive, and here negative. So positive, negative, it will give us negative t cosine t, negative, negative, plus sine t. And that's according to our integration from 0 to x, okay? So that will give us minus x cosine x plus sine x. Minus, substituting by 0, here will give us 0, and here sine 0 will be 0, okay? So this is the answer. Now let's work with t cosine t. Again, t is the one that will give us the 0 when we differentiate it. Cosine t will not, so you will take it as dv. So differentiate will give us 1 and then 0. And cosine t integrated will give us sine t. The integration of sine t is cosine t, okay? Cosine t minus cosine t, sorry. So again, multiply this term by that, this by that, positive, negative, okay? So here we will have t sine t, negative and negative, it will give us plus cosine t from 0 to x. That will give us, when substituting first with x sine x plus cosine x, minus, when we substitute with 0 here this part will vanish, and we have here cosine 0, it will give us 1, okay? Let's do the third one. We will take t squared as the u, and dv will be sine t. Okay, so here we will differentiate t squared. It will give us 2t, and then it will give us 2, and when it will give us 0, we stop. Sine t, we integrate it. It will give us cosine t minus cosine t, and cosine will give us sine t, and sine t will give us cosine t, minus sine t will give us cosine t, and then finally cosine t will give us sine t. Okay, okay, so we will multiply this by that, this by that, and this by that. Okay, sorry about that one. So plus, minus, and plus. So we will get, here it's plus and here it's minus, so it will give us minus t squared cosine t. And then minus minus will give us plus 2t sine t. And then here plus plus will give us plus 2 cosine t. Okay, and that is from 0 to x. Okay, so minus x squared cosine x plus 2x sine x plus 2 cosine x minus substitution with 0. The first one will vanish, the second one will vanish, because of here of course t squared and here is t. It will give 0, and the last one cosine 0 is 1, so minus 2. Okay, this is our answer. Do the last one as a homework. Okay, it will be the same, it will be easy. Again, if you want to check your answer using Mathematica, okay, you can use it. Here I write t squared sine t, okay, to check if the solution is right or wrong. And in the first input, as you can see, t is from 0 to x, and you can write it like this: integrate t squared sine t, t from 0 to x between parentheses. Or you can write it as we did, escape d in t t, and then escape again, and that will give you the form of the definite integration, and then you write at each square what you want to write and evaluate it in the end by pressing at enter. Okay.